Okay, my friends, this is going to be a lot of fun. I love this guy, Anton. Nice guy. And he's talking about dark matter, incredible experiments to find dark matter. Now, I've been doing this for quite some time, and I have some claims about dark matter, and I believe I can show you very simply what dark matter is. It's the muon. Okay, my friends, Roger once again, and I am about to alert you to the fact that I found dark matter 6 years ago. I posted about it and I said dark matter is light on its way to hit the Earth, and it is. Dark matter is involved in light. Light is not just a glowy part. This is what light really is. Light is this. It comes through as these particles. They have the black and they have the white. And CERN found them and Fermi found them as well, but they found them in debris. We found them in a stream of particles because we do it correctly. We do it with a stream of particles, crushing the fields into each other this way. They tried to hit them head on with gigantic, huge particles, and they just created a bunch of trash. We could see the actual particles coming forward. We see them speeding up, we see them dividing, and we see them coming back together. That's pretty stunning. This is what the particle looks like as it's traveling. And the forward leading part glows and ends up flipping, and then this one comes to the forward and starts to glow, and it flips. That's called the muon wobble. It goes through flipping and flopping as it goes through the air, charging and discharging. We have done exactly what Fermilab and CERN would like to do, except they use gigantic particles and they create literally trash, and then they dig through the trash to find these particles. We can actually see them starting. Well, here they are. Here's what happens as the light comes through the air. Let me turn these lights off so you can see it better. This is what happens when light comes through the air. It is speeding faster coming towards our Venturi. This is why we see these so excellently. These up here you can't even hardly see, and you wouldn't see them unless they were being funneled down towards this Venturi. You just can't see the particles. I agree with that. However, in our setup, we can see them exactly as they start to propagate. These are the different neutrinos. This is a neutrino, that's a neutrino, these are neutrinos, that's a photon. It happens in red, it happens in green, it happens in blue. Here's the green doing exactly the same thing, creating exactly the same particle. Creating neutrinos back here. As they concuss, they absorb more energy. So they become heavier or lighter. It depends upon where they are in the stream. That's why they say neutrinos change flavors. Yes, they do. This is a heavier one, this is a lighter one, this is a photon, this is a tau, this is a, so forth. They know all of those different energy values are involved in light. They just have no idea why. And it's because they're stacking up against each other. They're pushing their field against another field. Now, I'm going to break it down for you. This is nothing more than light coming forward. Pulsed red laser. Boom, 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 boom. Inside here is the particle, which is this particle right here. You don't see it. You can't see it. The only reason you see it here is because we are just about ready to go through the Venturi. Here is way back. It's starting to accelerate. That's the only reason you even see this at all. You wouldn't see these light waves at all until they start to accelerate, literally breaking the speed of light. That is acceleration. No question about it. If you can't see acceleration there, you got problems with your eyeballs. That is acceleration. That wave before was like this and this and this, and it just kept going that way forever, except it has to accelerate to get through that Venturi. Alright, before I even start, I am going to brag about saying this 6 years ago. Light is dark energy and dark matter in the vacuum of space. Light is dark energy until it hits something, which is matter, and bounces off. That's what light is. Light is liquid, literally liquid, and dark energy and matter as it transits space. Alright, these are all about dark matter that I put up back then. It seems dark matter makes black holes and is half of the light. I show all of the different documents. Light is liquid, dark energy. 6 years ago, I did this. Now, then I went into Mudfossil University. They destroyed that channel because everything I put up was suppressed. But anyway, it's all come true. Okay, I'm just going to explain to you right off the bat what my theory is based against what their theory is. They say all these different particles are different elementary particles. That is just not true. The only two of them there is these two right here, and they make everything. And that's my theory right here. Is these here, one glows and one is the dark matter. That's dark matter, gravity, weight. This has almost no weight whatsoever, but it has a huge field. And that's exactly what they found at Fermilab. And then there's different colors which are attached to the black. The black stays the same no matter what flavor it is. And the flavors are the different colors, the different impact. And they always normally travel together or in clumps. In clumps, they turn into matter, just like this. But every one of these is a magnet. It's just a black and a white. And I show you this. I'm not guessing. I can show you. And I'll explain to you precisely what every one of those particles is. Because here's really what it boils down to when you separate them out. These two make everything. The Higgs is nothing more than the surrounding two together reincorporating into a photon, into an electron. And this is nothing more than a gluon, which is nothing more than an electron. And two gluons together make light, which is the photons. Everything else is just variations of these two particles. And these are just variations of these two particles. That's all that exists. Now, I'm going to show you, actually show you those particles. Okay, this is Coursera. Now, I went to school for physics and chemistry and all of that stuff. It's electricity. I was in electronics basically my whole life. And that is nothing more than material interactions with fields. I mean, I understand that stuff very, very well. And this is my new model. I went to Coursera. I took two classes from Coursera. I went to University of Geneva for particle physics. I went to a whole batch of them from Coursera. You go for free. See, it's free. This one here is Introduction to Particle Accelerators. That's free. Understanding Modern Physics, Complexity. That's free. You can go to all these schools. They don't give you a piece of paper, but I didn't care about that. But I learned exactly what they were saying, and I can show you what they are saying. They don't really understand the particles that are involved, and I do. And I could prove it. So I'm not just guessing. And I did present this to them. And I think it made them sit up and listen because they were very, very nice to me. They were very cordial. But that's as far as it went. And that was probably 6 years ago or more. Now, this is another one. Don Lincoln, he gives lectures all the time about things that he's not right, but you can go there and watch. They did find the dark matter, and they found the glowy matter. Same things I'm going to show you long ago. And I said to him, I said, these are the particles. I tried to work with Don Lincoln. I said, I got the exact same particles. And I was blown away. Just don't bother us. And I said, the space is filled with the quantum foam. That is dark matter on its way to hitting Earth. And I did all the videos 6 years ago. Totally rejected. Okay, so my claim is that a proton is not a big chunk. It's 1,823 of these dipoles. Each one of these is like a little tiny bar magnet. I'm going to show you this actually happening in our light experiments. I can see it. That's why I'm making these statements. Now, this they would consider a proton, and this they would consider a neutron. A neutron is only one electron larger than a proton because it becomes neutral. So 1823 is 1824. Now it's neutral. It doesn't want any more and it doesn't want to give any up. This one wants to attract one or it wants to push one away. It depends on what it's coming up against. These are what you actually have. Now they slam these together and they just see all kind of debris. They've seen the dark matter. Didn't realize they saw it. This is dark matter talking about it from CERN. Invisible dark matter makes up most of the universe, but we can only detect it from gravitational effects. No, we have seen it in light, and I will show it to you right now. It is part of light. Now, once you add it together into a mass, the dark goes inside. That's why it's dark. You can't see it. But that's what makes up the weight of everything. That's why this weighs something. Otherwise, it wouldn't weigh anything. That's the only reason these weigh things is because of the dark matter that's inside. Simple as that. All right, we're going to come back to this in a second. But remember these terms, dark matter and dark energy. Now, this is CERN. And they're talking about, unlike normal matter, dark matter does not interact with the electromagnetic force. It says what they mean by that is it does not absorb energy, it does not reflect or emit light, making it extremely hard to spot. I agree with all those things. There are things I don't agree with, and the standard model and so forth, we're going to go through that in a second. But dark matter and dark energy is what we're going to discuss right now, and I'll show you both of those things actually happening. Okay, as I probably already mentioned, one of them is it's just exactly like Don Lincoln says, it's a fixed particle, never changes, and one of them glows, but it has a huge field. They see it from collisions of debris. I see it from light. Not only can I see these particles and demonstrate them in all the different colors, we also know about the quantum foam, which he agrees with, as the space is filled with these particles. As I said to him 6 years ago, I said, these are light particles, but they also carry dark matter with them. Everything is combined. Okay, let's just go with this. The whole idea of research is so that you learn something, you put it to use, and get some benefit from it. I think we can do that today. Not with this. This is just way too complicated, and at some point it may yield, but not today. All right, I'm just going to leave all these up at the same time. You don't have to see the extreme details. This is Dirac neutrinos. It's got a black and a white. Yes, they've got a black and a white, well, black and a red, whatever you want to call it. And we found them, yes. We accelerated light, yes. We created Higgs fields, yes. We created the different neutrinos and the photons, yes. We created the exact same particles that CERN's looking for, and then we divided them into the muon and electron neutrino, yes. There's a muon neutrino, electron neutrino. Attached together, that's a Dirac neutrino. Smashed here, the muon doesn't do anything. It's a fixed particle, exactly like Don Lincoln says. This turns into showers. It's exactly what we did. They cannot do this because they're working with huge particles, smashing them together and seeing literally debris. We are seeing the actual muons. We're seeing the electron showers. We're seeing them come back together where the Higgs fields reattach to particles. Once they divide apart, they have to come back together, and that's where it happens. These are the different flavors of neutrinos. I believe these are the tau down here, and then there's different ones. Then they turn sideways, and then they turn into photons. This is because we're directly in line with the Venturi. That's where it splits here. But you still have photons up here. But they take on different neutrino values as they concuss differently. All it is acceleration or concussion. It creates different frequencies and different energy levels, basically. And when I say different energy values, you can see this is not as energetic, the red, as it is the green. The green is much more powerful, and when it comes out of the Venturi, its energy just forces the red to get out of the way, and it just takes off, and it re-impacts out here. The red's done. The red is just, it's not strong enough. The blue is even much stronger than the green. And here's the blue. Look at the blue. It comes in like a rocket ship. You can't even tell there's two whites here until you get way out there, and then you can just start to see them. But it's coming, the frequency is packed tight, and now it opens up. That's just exactly like the red shift. The universe might be expanding, but everywhere you look, it's expanding. Why would that happen? It's just slowing down as it comes towards us. That's the nature of light. It has to go through the particles. And just like Don Lincoln says, empty space is not empty, it's filled with the quantum foam. And these are light particles. Just, you know, we could see all this stuff because we're using CMOS. And we were using this in I think it was 2013, 2014, picking up these particles, and I tried to report this to everybody, and they understood it. I think it's just it didn't have enough money in it to fund their super colliders, which we don't need. Right here, these are the particles they found in the super collider. Well, guess what? What's this? Identical same particles. Only I can show them expanding. I can show them contracting. I can show them moving through the air. I can show them accelerating. I can show them exploding at the Venturi and turning into the Muons and the electron showers. I show all this stuff. And this was 6 years ago. And I tried to present it to everybody. Now, I think I had some influence on what they did at CERN, because I went to the University of Geneva through Coursera. But they were very cordial. They're very, very nice to me. And I showed them. I said, you got to squirt it through a Venturi. You can't just let them go flying by each other and hope something hits. And that's all they were doing, apparently. So then they actually shut down and made it focus. And then they started using CMOS. Because I said, we were using CMOS. We're just using a smartphone. And that's all it was. I showed this the other day. All it was is a tiny little laser. We spent a few $100 did all of this. And the CMOS in that Samsung Galaxy S3 phone from back, I think it was 2014, maybe even earlier. That sucker works fabulous. And the selfie side was what Rod Warren used to do this. And he just picked it up by accident. When I saw these particles, I said, man, you're ahead of CERN. You're ahead of Fermilab. You're just unbelievable. And he had no clue what he did. He was just seeing this stuff and thinking, wow, look at this. And he did it because he created a Venturi instead of a flat plate slit. And a Venturi forced the fields to collide sideways. And just the exact same thing as hitting head-on. No difference whatsoever. That's why we have all this magnificent physical evidence. There's no just calculation. We're hoping if we did this or that, maybe this would be here or maybe that. No, here it is right there. That's photons of light. That's all we used was light. We didn't use protons. So it's time to reconsider at Fermilab, I would say. If they're supposed to be working for us, I don't see that now. I'd like to see a change over there. This is what I'd like to see. This would only take a month. 1 month with a couple of engineers and a little fabrication shop. Create the Venturi. Figure out where the laser works best, what energy levels, how many pulsations per second, you know, that type of thing, and what material you use and what collector you'd have, and see if we can, first of all, you want to see if you can harvest energy, and I don't see any reason to think that that's not going to be very, very energetic. They say at least 207 times the energy coming out if you can separate these particles. We absolutely separate them, no question whatsoever. So we should have at least that, but I see that it might be even much more than that, because right now they're not right about anything. So don't take anything for granted. Nothing here is for granted. My stuff is not for granted. My stuff is visible. Let's work with that. Don't just start guessing and saying, oh, look, stay away from that guy, he's crazy. No, I have physical evidence, and anybody can do this very, very simply. This was just an accident. All right, so I'm just asking somebody to do this. If we're supposed to be working for us, if we could get some free energy, that's fabulous. Let them go on about smashing anything they want to smash. But if we can get free energy, to me, that's what this whole thing was about in the first place. Okay, if you're on planet Earth, you've been seeing, everybody's talking about bizarre dark energy, new way of approaching it. We now understand dark energy now. They don't understand anything, because dark energy is nothing more than light. It's the other side of light. It's the dark behind the light. Another one, hyper interactive particle relics, a new model for dark matter. It's crazy. They know that they have a real problem, and they refuse to address my research, including Fermilab, CERN, and all of them, who I have interacted with. And they agree with me that my evidence is exactly what they're looking for, and they will not speak. The thing that's most upsetting is they know my work is correct. The LHC they wanted to use as a photon collider, not protons. Protons are hundreds of billions of particles. They smash them together, they get garbage, just nothing but trash. The physics of photon collision has been a topic of some interest for many decades. A special meeting in 1978 discussed the prospect of such collisions, but it just fell through. Years ago, the project didn't materialize then. Well, they won't let it materialize. It's too good for them. They want to spend billions of your dollars walking around in circles, and they have successfully sucked money from your pockets to do absolutely nothing. Here's another one. They say electrons spin in quantum physics. After all, wow, here's why. They spin because they charge and they discharge, charge and discharge. Okay, CERN, Fermilab, they're all still touting the standard model. It does not work. It is wrong. 100%, no question whatsoever. All right, pay attention to this. They say, oh, they've made fabulous new discoveries. They're showing all these different particles. They are not different particles. There's this particle and that particle. These are the only two that exist in the universe. You put them both together, the black and the white, you end up with an electron. Let me show you. Simple as this. CERN and Fermilab, they see these two particles just in trash. This one never changes. That one gets glowy and big and small and puffy, and that's exactly what we found. Only we didn't hit head on. We crushed them through a Venturi right here. So we could actually watch the two particles separate. The black separates from the white. Here's what it was. Just a second before, well, instant before it went through the Venturi. It was these particles. This one is the leading one, charging up, and then it'll flip, and this one will come in front. That's how light travels through the air. It charges, discharges, charges, discharges. That's what creates the muon wobble, the flip. And we show these, there's no question what I'm showing here is true and accurate, and this is light. We used CMOS from a smartphone, fully understands that it works. It's called MOSFET. Metal oxide silicates field effect transistors. They turn on when they get a pulse of illumination. That's what we're picking up here is the MOSFETs. They understand this. They just refuse to engage because it destroys their particle physics standard model. It just completely crushes it. Okay, that was a pretty unfair statement. It doesn't totally crush the standard model. It just reorganizes it into a point where it's reality. Right now, they just don't understand it whatsoever. They really have no clue because of the way they do their collisions. We have used particles of light. We did the photons, which CERN tried to do back in 1978. It's like 40 years ago. Okay, now, I think I showed you this about Coursera. You should go up and get these courses. They're free. And you could go into their catalog, and I mean there's a million of them. Now, you can also get a piece of paper if you want to pay something, I'm sure. I never really looked into it, to be perfectly honest with you, because I don't care about that. But you might. And but I would look into this. They were very good. Everybody was good. Plus, I went to Yale for quantum physics. For quantum mechanics, you don't have to pay anything to any of these places. You can go to almost any of them. They're online now, but you don't get any credit. Now, I went there just to basically see what they had to say because I knew my stuff was not going to be what their stuff was, and sure enough, it wasn't by a long shot.